Hello there everybody, hope you're doing okay. It's a Sunday night for me when I'm making this video because I was a bit busy on Friday and that, so partner is watching TV in the living room, so I'm in the bedroom making a teaching video. But here, that is 2021 remote learning for you in a nutshell. Now, our topic has been weather, and we've been tracking the weather in Scotland with our chart. We've made a windsock, we've made a rain gauge, we've looked at how clouds are formed, because we know there's a lot of clouds in Scotland. We also looked at why hot countries are hot and cold countries are cold. We looked at negative numbers to help us understand temperature, going from below zero to above zero, and we looked at weather forecasts too. And now I thought it's time to learn about some extreme weather. So, we're going to learn a little bit about tornadoes today. Now, you might be thinking, we don't get a lot of tornadoes in Scotland. But believe it or not, the UK gets 33 tornadoes every year. That's almost 3 every month. That's crazy, eh? We wouldn't have thought that. The thing is though, our tornadoes tend to be very small, and they also tend to be out at sea, usually where we can't see them. However, most tornadoes can be found in the United States. They have about 2,000 every year, and they're huge. For all the incredible things that science has allowed us to understand, when it comes to tornadoes, there's still a lot of things that remain a mystery. So for this lesson, we need to do 3 things. We need to learn about high and low pressure. What is that? What does it mean? Once we understand that, then we can look at how tornadoes are formed. Once we get a good understanding of that, we can build our own tornado in a bottle. So let's start by looking at how a tornado is formed. Now, to understand this, we need to look at high and low pressure. High pressure, beginning with and we think of alliteration, high pressure can be known as happy weather. If we have high pressure, we're going to get sun and maybe a few white clouds in the sky. Why does that happen? Well, it's because the high pressure on the ground drags the cold air from up above down towards it. Now you might think, well, is that not dragging rain? It doesn't. What it does is cold air, when it comes closer to the surface of the earth, has longer to heat up from the sun. And so we get nice weather down here, and there's less condensation up in the sky as well. So we're going to have less clouds. However, in areas of low pressure, and we can think again of alliteration, L for low, lousy weather. Lousy means rubbish. So low is lousy, high is happy. In areas of low pressure, what happens is there's cold air near the surface of the earth, and it gets dragged up where it gets even colder, more condensation occurs, and big clouds form. Now, at this point in the video, you might want to pause, rewind, and watch that again. If not, you could pause on this page even and just think to yourself, how does this make sense in my own head? What is high pressure? What is low pressure? I'm going to give a wee test in a second. So did you pause? Did you have a wee look? If not, just rewind quickly. If you have, you feel quite confident in telling what high and low pressure is, are you ready for a quick fire test? Okay, when cold air sinks, is that high or low pressure we're seeing? It is high pressure. What's happening is the cold air is being dragged down to earth where it has more time to heat up, and we get nice blue skies, sun in the sky. Okay, second little test. Can you pause the video? Can you draw me a diagram or an illustration? So a drawing. Okay, can you show me low pressure? Could you show me a diagram or an illustration that explains it? Go for it. Okay, definitely paused it. Definitely drew it. Okay, here's mine. See, so yours looks similar. I'm showing here that when we've got low pressure, we've got cold air near the surface, then it rises up. More and more condensation occurs, and we know that with lots of condensation, clouds are formed. Right, we'll leave it there for the moment. High pressure and low pressure. Next, what has that got to do with tornadoes? Well, for a tornado to form, there needs to be something big in the sky. It's called a supercell, and it's formed when there's lots and lots of low pressure that creates tons of condensation up in the sky. Supercells can be ginormous, and they bring with them a lot of thunder and lightning. The lightning storms created by supercells are both beautiful and terrifying. So what we end up with is this ginormous, massive energy up in the sky, known as that supercell. It's a huge, huge cloud going miles into the sky, and it's got a lot of energy that creates this lightning. Now, have you ever heard the saying, opposites attract? It's why magnets stick together. There's something called a positive and a negative charge, and positive and negatives are drawn towards each other. Sometimes people say in life as well, when you're looking for a girlfriend or a boyfriend, that sometimes opposites attract. So a quiet person is attracted to quite a loud, boisterous person, or the other way round. In fact, that's a good question to ask a grown-up in the house. Do they believe that opposites attract? Well, back to our supercell. Low air pressure drives cold air up into the sky where there's increased condensation and we get these massive clouds. But wherever there is low pressure, high pressure is attracted to it. Now, when this happens in an area with lots and lots of energy and massive clouds, with low pressure pulling the cold air up and high pressure dragging it down, we start to get a circular motion going on. So back to our supercell cloud. As this low and high pressure come together and start to circle, what can happen is the cloud can be dragged down towards the Earth in a spinning motion. And so what we end up with is low pressure pulling air up, and it drags around the side of it. High pressure drags down that condensation. So at this point, I think it's a good idea just to let the weather do the talking. Just sit back and see what's going on here. Now, just a wee side thing to note, there are 5 categories of tornadoes that we know of. We've got an F1 all the way up to an F5. An F1 starts at about 60 to 80 miles an hour. That's as fast as your car can go on the motorway. So that is really, really very quick. 70 miles an hour if you ever stood next to a motorway. But pales in comparison to an F5 tornado, which has gusts of up to 200 miles an hour. Now, it's interesting to note that the largest tornado ever was in Oklahoma, right near Oklahoma City. It claimed 36 lives and damaged around 600,000 houses. The destruction caused was quite incredible. Whole neighbourhoods were just levelled and people were left without a home. And I think right before we move on, it's a good point to pause and stop and think and reflect on how incredibly powerful the natural world is. We as humans, we've done amazing things over the past 8,000 years, say, from going back to the Egyptian pyramids all the way up to the iPhone that I'm filming this on and going into space. But we still have no way of preventing things like tornadoes and tsunamis and earthquakes. And I think it shows just how powerful the world is, the natural world that is, but also how we have to respect the natural world. We have to look after it. We've only got one after all. But now, I think it's about time we moved on to making our own tornado. Now, to do this, I could just ask you to spin around in a circle. But you get a little bit dizzy. Instead, to create your tornado, I'm going to get you to use a bottle. Now, it could be a glass bottle, it could be a plastic bottle. This is one I used for adult juice on Saturday night. Now, I'm going to ask you to go into your bathroom or to your kitchen sink. Look at this. Get a whole tour of my house these days. Anyway, I'd like you to fill up your bottle. All the way right to the top if you could. Now, once you've got it filled, I'm going to give you a challenge. How quickly can you empty your bottle of water? Well, I don't need to drink it. I could just pour it. Oh yeah, so I could. Right, so if I pour my bottle, it will empty. It's not bad. Maybe it's 6-7 seconds. Now, one thing to note is when you turn a bottle upside down, Air is trying to rush into the bottle because air always tries to fill a space. And so there was water in the way. It's trying to get to the top of the bottle. There's water in the way. It kind of slows everything down and you get that kind of glug, 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 glug thing going on. So hopefully I'll see if I can show you this. Can you see? We get that kind of glug, 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 glug. And you can see the bubbles from air travelling to the top of the bottle. Now, with a tornado, a spinning column of air, it creates what we call a vortex, with air rushing up to the top to fill the void in the middle of the cloud. Get this thing. And with a bottle, we could create a vortex to show how that air travels quickly to the top and pushes the water down. Right, so I've got my bottle here now. I've filled it up to the top. Now remember when I tipped it over last time? Okay, all the air bubbles were rushing to the top. They're trying to fill that gap. Well, if I spin this round, watch what happens. Okay, get spinning, and I'll let go. Did you see that? What I'm doing is, as I spin round, the water's going round in a circle, and I'm creating what we call a vortex. It's going to be a column that the air can travel up to the top of the bottle, and the water will be pushed out. Can you see it? See if I can get a really good one for you. There we go. That's more like it. So before you go and try it out, just watch this next bit and make sure we actually understand what's happening. As we spin the bottle round, we're creating a channel for the air to quickly shoot up to the top. And as it does so, it's still obviously spinning, and it pushes the water out. And that is similar to what's happening with a tornado. Air is rushing to the top of the tornado and pushing the condensation downwards. So find yourself a bottle somewhere in the house. The bigger the bottle, the better, usually as well, and give it a wee go. And if you want to explore tornadoes more, here are 4 videos that I highly recommend you go and watch. You can see they're all quite short. It's got the tornado tube experiment with the bottle as well. Talks about how tornadoes form. That's a TED talk as well. And then there's some fantastic images of tornadoes which show how beautiful and also terrifying they can be. Fantastic. Thanks so much, guys. See you again for another weather lesson soon.